All right. Looks like we're live now. There's Santa. Resized. It's taking forever. What's up, Brandon? Give everybody a couple minutes to get in here. And while we wait, I think trash guys are here. I'm going to do that real quick. All right, that's taken care of. All right, so this is finally finished uploading. All right, so let me go over some of I got some prints done on the HyperCube. I want to make sure everything was working right. And I have to say, I am, number one, in love with this screen. It is working out really well. It's super responsive. There's a lot of options in it that like you don't normally see in Marlin, especially older. I mean, this is Marlin 1.1.8. It's a much older version of Marlin on this. So, but still working absolutely fantastically. So I've got some PDG lined up here because the parts I designed tonight, I'm going to go ahead and throw on this to print for itself because why not? But I had issues. This thing would not properly print Jesse PLA, the black. I kept getting, I think I failed print here. I end up getting under extrusion. After a few millimeters into the print, it would start under extruding. I have no idea why. I upped the temperature all the way up to 225°C, still got it. It just, this material is not working out with this printer. So I went ahead and loaded up this like no-name brand. What brand is this? I don't even know. But this blue I bought for some blueprint prints. Oddly enough, it just says PLA. There's not even a brand on the spool. But I don't even know who it's a rebrand from either way. But it printed just fine. So first up, I printed the MakerMuse tolerance. Come here. So I recently bought this from Angus, and this is his tolerance test. So we got 0.5 works out okay, 0.5 works out good, 0.3 is good, 0.2 completely fused. So 0.15 completely fused as well. Thought maybe it's like a miss issue, but in the middle section as a fidget spinner, it works just fine. But so we get all the way down to 0.3, I think probably like 0.25 was what my tolerance ends up being on this printer. Not great, but I mean, it is what it is. It still works out well. I don't need to print high tolerance parts on this printer, but that's that. On cooling though, it does a great job. So this is the makerbot overhang and bridging test. You can see all the different degrees as it goes up, and then it's got a 1, 1.5, and 2-inch bridge there. So you can see there's not a whole lot of drooping on those bridges. It's actually really good for that. It's quite a long bridge. 2 inches is quite a long bridge to do. And as for overhangs, this being 20% and this being 70%, also really good, because honestly, these are unsupported overhangs. So most models, when you're designing, you're going to try and stay right around here. So this is 50 degrees right here. You're going to try to stay 45 degrees or 50. And I think usually slicers by default are set to like 40 or 45 degrees should have support. But even 50, 60, sorry, we have 40, this is 50, this is 60. 65 is where we start to see a little bit of issues, and then 70. Am I ever going to print an overhang with 70? No, but with that 50-15 fan that's on there, it does a really good job, and that Ultra Base gives it that really nice, more matte bottom. I don't like how glass is like super shiny. I used to like that, I don't anymore, but Ultra Base holds on really well, and our surface details, all the filling and all the numbers, everything like that look perfect. All that works really good. So those are the two models that I got printed today on the printer. Again, just making sure everything's functioning right and whatnot. And I'm trying to decide on what I want to do to this printer moving forward. I want to make some changes myself, and we're going to start doing that with tonight's Fusion session. The first thing I want to do is change out. Let's go back here to this one. Okay, as far as we get. So the first thing I want to change out is this 30mm E3D fan. It's super loud. It's very old. I built this thing a few years ago. Yes, it still works, but man, does it suck. I did have to replace the cabling in there because I was using this more solid wire with not proper wiring whatsoever, and it would not solder very well anymore to the other copper wire. So I pulled this out and pulled in some new wire. I've got my spool holder sitting here. So I went ahead and pulled new cable through here and got that rewired. It's working, but it's just really loud. I'd rather put a really nice sun-on fan on here on the front, which would mean I have to rotate my heater block. Right now it's in the front. I would just rotate my heater block to be more in line, kind of more traditional style, which would bring the cable over here to the side, and then it would go up. So I already found on Thingiverse a 40mm mount for this, so that I don't have to worry about. But I've also been debating as just leveling this thing is not the easiest thing in the world. So I've been thinking about doing ABL. And I have several easy ABL kits from TH3D. I really want to use them. I like them. They're simple implementation. They're easy to wire in. So I'm going to go ahead and redesign this back carriage piece so that you have the main carriage, and then this, what holds the hot end on, bolts onto that, and this is just a clamp that goes on the front here. So I just have to redesign this one piece to come out and have the easy ABL. Now when I pull all the way over to here, this is the only place that I kind of have a little bit of a clearance issue, but I'm never going to be there. I'm always going to be back here where the actual bed starts, and I have a humongous amount of space here. So as long as I'm not crashing into this front corner, should be square. Shouldn't be any issues at all. So really can not have to worry about where I put that. And on this side, I don't want to put it because when I do home all the way, I'm more limited in my space right here between the carriage and this stepper motor. So we're going to put it on the right side of the hot end. The other thing you'll see here that I did go ahead, design, and print are the new bed mounts on here. So someone gave me the idea, I think it might have been Jim, that said, hey, you should go ahead and use some corner brackets, like the 2020 or 2028 corner brackets to use for bed mounts. I was like, well, that's a really cool idea. So I have some 2028s here. The problem is that from here out is 18mm to where the end of the extrusion is and where the bolt comes down from the bed. I can't change that. Those are attached to this bed, so there's no way you can change that. And this is just not quite wide enough, doesn't go out far enough for that to match. It looks like it does, but I would have to get the Dremel and remount this hole in here in order to make that work. So I was like, well, corner bracket. All right, I'll go ahead and design some. So I'll show you the design here in a minute, but I just did some quick dirty measuring. I went ahead and created 2 of these. These ones have the little like toggles in there, I guess, like for alignment so that it doesn't twist at all. This one does not. So here's a close-up of it. There it is. So just went ahead, and this is big enough so this will fit the spring down in there. The spring can't wiggle around. This is for an M5 pan head screw, bolt I should say. Little design feature, why not make that like that? And then again, the other one has kind of like a line going through here just so it can't twist in the extrusion at all. I want these to stay nice and solid. And you can kind of see the tab in there, and these right here and right here, you can see those tabs in. So very easy. It took maybe, I don't know, 15 minutes to model, 10 minutes to model, super quick and easy. Printed it up on the Mark III's. I printed one with toggles, one without, for the alignment, and decided on that one. So threw 3 more on there. Well, not even an hour later, they were good to go. So I think they are working out well, I guess. The only thing that I would change, I think I know what I did when I built this. I built it 90 degrees turned. This over here, this should be Y, and this should be X, because it is cube, but it's not precise. Let me measure it real quick, because I think that's what I ended up doing by mistake. So we're 373 there. Yeah, we're only 345 here. So I think that's what I did. This should have been this all should have been turned 90 degrees, because again, I'm over the bed here in the front, and I can't get to the edge of the bed in the back. 2 things I could do to solve that. One would be to cut longer extrusions for here and here to pull the bed more forward. Could do that. Or 2, completely disassemble it and spin it and rebuild it. Right now, that's not what we're going to do, because I really don't want to do that. So we're going to leave it the way it is for now. But again, this may become the carcass for the Core XY that Aaron and I are going to work on later this year. This might end up being part of the frame that I'm going to use, just adding a few more parts or change things up. But I think we're going to keep it to 2020 or smaller. And I think it'll end up working out pretty well. I did also have some issues with the extruder. It was acting up on me, and after a few years of use, this is the 608ZZ bearing that was in there, and you can see there is a groove worn into it after several years of use. And it wasn't even like extensive use. Like, it was just like, you know, a couple hundred hours, I'd say, less than 1,000 hours on this printer. Wore a groove into a 608ZZ bearing. So I got a new one on there now, and that seems to be doing well. I did swap this out before ruling out the Jessie PLA being an issue, and Jessie PLA was still an issue. So that's why I went to this other filament. I don't know why it's not cooperating with this hot end. I also went ahead and swapped out the nozzle. I have the old nozzle right here. I also swapped out the throat with I think a better quality one. Where'd the other one go? I think I also ended up, yeah, so here's the old heatsink. So this is a very cheap, super duper cheap, thick looking heatsink. Like, this is not anything fantastic, but I went ahead and took this out, and I took out the throat with it. I just don't know where that went. It's on my table here somewhere, but I went ahead and swapped that out as well. And as you can see, I'm able to use these bed knobs now. I was using these tiny, tiny little thumb screw head nuts, which just sucked. Come on, focus on my bleeding hand. There we go. No, you lost it. Come on. God, this camera sucks. So much money in this camera, and that focus sucks. There we go. I was using these, and yeah, these were not working out. They were very hard to turn. These are very easy. They also come with these super beefed up blue springs. So these are the same ones that Creality uses. The orange ones are M4s. These blue ones are M3s. And that's what comes on this bed. So now they're very easy to turn. I have enough clearance below the extrusion I was worried about that, and then I was worried about my clearance between the bed and the top of the extrusion here. So that was another big issue that I had to worry about when designing these new parts. These are printed in PETG because they are near heat. We'll see how they work over time. These were the original ones. These are the original ones that Tech2C made. So they would used to go on to the extrusion like so, and your bed came through here, and then you would tighten the little nut under there. They work, but I had compressed some of them just so much that they got like a dimple in them. Focus on my hand. There we go. See like that dimple in there? Because I had to compress some of them so much. But these are 5 top, 5 bottom, 4 perimeters, 20% infill. So they are plenty strong enough for pretty much any extended amount of use. I think they'll do well, but hey, time will tell. We'll see how it goes from there. Okay, so let's jump into Fusion360 here. And we'll just go right there. Okay, so let me pull that up right here. So here's the HyperCube bed mount V3. The only thing is I have to put back on those parts. I had power outage last night, and I forgot to save this, so it saved when I undid it in order to do that. But it's a pretty simple thing to do. I'm just going to go right here into this sketch, and we're going to draw a line out. So I made it at, so this is the end right here. This center hole is the end of the, where the bolt comes through. So you obviously don't want to impede that. So that's 2.7. So we're just going to go out to, what, 4? Did I do 5? We'll go out to 4 there. Get another line here. Yeah, stop it. Line. We'll go 4 in that direction. Okay. And then we're going to do another line here for, we're going to make this 4. Here, we'll go another 4. And then I went and made it. So I also, you measure the inside of your extrusion. Not all extrusion is different, but depending where you get your T slot from, or if you're using V slot. So if I go ahead and measure mine, I'm sitting at 6.3. So I'm going to go ahead and make these 6 millimeters. So I'm going to go up by, make a line, go up 3 here. I'm going to go ahead and make a rectangle down here. Go down to, call that 6. And then that is going to be an even amount in there. I'm going to do the same thing. Rectangle. Well, I'll do a line up here first. Line up here, 3, rectangle. There's 4 by 6. There. Okay. Now I can make these center lines. I can hit X so that those are just, what's that called? Those are the dotted lines, construction lines. There we go. Here's a sketch. Enable that sketch. And we're going to go ahead and extrude this. Just going to extrude it 2 mil. Okay, so we have those registrations. And then we're going to go ahead and add a chamfer to them here, just so they slide in easier. Go away. So we'll do just a 1 mil chamfer on there. And that's it. So I did add supports on the bottom of these. You could make them a little bit smaller and a chamfer on the bottom, and then you would need support, but the amount of support they need is really nothing, so I'm quite okay with that. But this is what I have there now. I might have made them a little bit wider than that, but either way, it's close enough. They look huge, but the one thing that Aaron keeps reminding me of is that everything looks enormous in Fusion360. These are tiny, tiny. These are 6 millimeters by 4 millimeters. I mean, they are smaller than the smallest fingernail you have. Like, they are tiny, tiny little registration marks. And again, this just prevents it from twisting when it goes into that extrusion. It's a nice positive fit. It stays flat. The other thing you have to worry about is when you do these is the orientation of your T-nut. So I always used the hammer twist-in T-nuts. I think they're great. They're easy to use. I did have a little bit of issue getting them, so I had to kind of back the screw out, turn it, and then push everything in, and then tighten it down to get it. But, you know, it's kind of here nor there. So, go back. So, Crazy says, power outage common thing. I've never cared about auto restart features because not too common for me. It's pretty common here. Rainy season just started for me, so we get power outages almost every night. So I do have to be careful on what I am printing and what I'm printing on. So sometimes if I have a very important print, I will make sure it's on something like one of the Prussias, or most of the machines have auto resume now, but like Megatron doesn't, so I won't print anything long term on that. The Bear doesn't because I'm not using an NZ board, but some of the other printers do have it, and I'll print longer things on those. Viking Obsession, Dan, what's up, guys? Um, yeah, so that's that piece. So we're going to save this again real quick, and that's done. X out of that one. Okay, so here I am now. Now we're going to work on the ABL sensor and see how we can get this to go. So again, I'm going to use an easy ABL sensor, which is 18 millimeters. It is a mammoth, a girthy boy of sensors. It is capacitive, which means it can sense anything that's below it, except bare glass, I think. But it can sense the ultra base. I know that because I had one on the CR10 before I got rid of that machine, but it left with a easy ABL on it. That's one actually I did the initial review and installation of it from Tim. And since then I've gotten a few more that I have to use. So it's 18 millimeters. It's a big sensor. It's okay. It'll work out on this machine for how I needed to, because again, it won't hit these motors. That's something you do have to worry about. I would like to use a smaller sensor, but I don't want to sacrifice one of my smaller ones that's going to go on some of the other custom machines I have planned. I'd rather use up what I have laying around, and that is an easy ABL. Quick drink here. So I found a model on Thingiverse that has it, and it is a horrendous model. So here's the mount. Then I arrange this. So here's the mount here. So this is the stock part here on the left, that part. And then they kind of like sandwiched on this gigantic chunk of plastic. And yeah, I don't want any of that. But I'm going to use it as a reference in Fusion 360 just to kind of know if I get everything in the right place. So, seems so a lot for that. What we're going to do is we're going to go Fusion. I have the step file for the HyperCube. Now, this does look to be a little bit different than my version because I believe I'm using Arthur's parts. Arthur went ahead and added in a bunch of captive nut holes for a lot of the stuff, and I'm using those parts. So I need to redesign that. Now, looking in here, this version of the HyperCube, this is Tech2C's most up-to-date version that he has ever put out, which was like 3 years ago. He stopped working on this. Has this kind of cutout here, and the sensor goes on there. So we're going to go ahead and use that if I can find it in here. So this is also a horrible, horrible, horrible model. It's step, which is good, but if you go to bodies, everything's just like thrown in there. So we're going to go ahead and select the body I want. And then it should show up as selected in here. Or if I right click it, I can do find in browser. So that is body 797. So we're going to go ahead and we're going to copy this. Let's get a new design going here. I can paste it in. No, I can't paste it in there. Copy. Let me do it, please. Repeat paste. No. We got to figure out how to get this out of here. So let's do this. Let's create component from body. Scroll all the way bottom. Now let's see if we can copy that out and paste new. There we go. In here. down a bit. We get that just to the origin of the new design here. To the origin. Okay, so we have that part. Great. Now we're going to come back into here. We're going to find the ABL sensor. We're going to right click it. We're going to do find in browser. That is 832. We're going to go ahead and create a new component from it. We're going to copy it. We're going to go ahead and paste new into here. It should bring it down, and it should line right back up with the original part like that. Perfect. See, we were getting somewhere. So we're going to use this as reference here for that, because whenever we're reprinting this back part, it's the same as what I have for the most part. Yeah, it's pretty much the same, and that's fine. And we're going to go and we have to bring in our new 40 millimeter front part. Again, I don't really want to design that, so I found one online. So we're going to just go ahead and create a base feature, insert, mesh, and then it should be down here at the bottom there. And we need to rotate it 180. Bring it over, try to line this up the best we can. I can realign it later, but I like to do it in the beginning so that all things are happy here. 6.5. Right there. Okay, so we've got that piece in there now. Fantastic. We're going to right click it, mesh to brep, new body, okay. Finish the base feature. Now we're just going to clean this up a little bit. Oh, I want to go back actually. So when you're still in the base feature, you want to go ahead and clean up your models, because that will allow you not to have all that in your history, in your timeline, and that just mucks up the timeline quite a bit, honestly. So I'm not like, oh shoot, I deleted the whole thing. This isn't like the best model ever, but I don't have to design it, so I'm kind of okay with it being not fantastic. Allow me to delete some of these faces. Again, deleting these faces just cleans up the model. It's going to need repaired. I can see there's some issues in here. Which is fine. Also, reducing the face count. Do that on that one. Reducing the face count lets Fusion run faster as well, because otherwise, I mean, every time I try to do something, it's trying to load all these doggone faces. Like, I don't want you to. I just want you to load when I'm working. Well, it's trying its darndest to load all of this information. Where if there's less faces, there's less things for it to load. Let's just check up here at the top. That's good. Underneath is fine. Again, I could do more, but it's okay. This will work out well. So get to that. Okay, so now we have our 40 millimeter mount. We can do finish the base feature. And we're going to go ahead and save this. New HyperCube hot end, just to call it something. Because it's raining, all the freaking flying ants are out now. And they are all over the place. Dave, it is a Windows. I think if you can do like a Windows STL viewer, and it was like a PowerShell, I believe, to run, and then it kind of loads it in. It's really interesting. I like using it. Makes life a little bit easier. So we're going to go ahead and color this blue to match. Save that again. Okay. So now we need to, I'm going to just create another component from this, just so it's easier for what we're working on. Okay. So we have the main body. We have the sensor holder. Then we've got the 40 millimeter fan clamp. Because that clamp the E3D, that E3D collet, that throat on it that clamps that in. So all of that is there. It's all aligned properly, and that's how it's going to look if I used a smaller ABL sensor. Again, we're not doing that, so we are going to just isolate this right here, like that. I'm going to go ahead and do some simplification on it by deleting the chamfers off of it. Again, this is just going to make it so it is easier to manipulate the model. I don't have to worry about any of those chamfers. They're only on the bottom. I don't know why, but they were only on the bottom of that. Now the key thing is going to be we're going to go ahead and create a sketch on the top of here. We're going to capture the position. And I'm going to recreate this circle. So it's 12.3. The problem, if I go ahead and do 18, we can see right there, it is going to overlap with the actual, and this is the inside diameter. This is not counting the extra plastic around it in order to actually like hold the sensor, because you got to have at least a few millimeters there, which this one is 12.5 and 16. So there's 4 millimeters of material. So either way, at 18 or at 22, we're way over there. So I'm going to create that for now. If I go ahead and create a line from here to here, it's about 5 millimeters too much. So let's delete that. Let's go ahead and make a line from here. Let's go over 5 millimeters. Let's do 5.5 just to be on the safe side. Now I can create my 18.2 millimeter. Let's do 2.3, and then a 22.3 millimeter. So that is where the new sensor is going to live at right there. Now again, there could be a million other ways on how to design and do this. This is just the way that I do it, which probably isn't right, but it's how I do it. So there is that. And then what we're going to do is we're going to have to create some new kind of supporting features on this. I think I'm going to I could do this, have it be a tangent line to that, and make that all plastic. It's a lot of plastic to use. Alternatively, I could just make this a little bit thicker and come straight down again. So right now, this is currently 5 mil. So we could make this, 10, be a thick boy, and then bring that down and attach it to there. So we could have that be there. And then we're just going to fill in some of this plastic's going to remain here. This part right here will get filled in, and we'll do all that through extrudes. And then when we're all said and done, I just need to put 2 extrudes right here for these 2 holes. Pretty easy and straightforward to go through doing that. So let's go ahead and, again, this is going to be a little bit funkier. So we're going to extrude all of this as the new ABL part. Okay, so we're going to go ahead and extrude that to the bottom. It wants to cut. We're going to tell it to join, and we're going to hit OK. Now it's going to look all kinds of funky. We need to go back, and since we have isolated it, there's our sketch. We're going to turn that sketch back on. So we need to then extrude this part to get rid of it. So take that all the way down. Okay. That's gone now. And then I kind of want to change up the way this all looks, because I don't really like that. So it does serve a purpose though, because this it's like an L, and it's kind of like sandwiching on there, and it gives you more surface area to be able to hold on to that sensor. Because again, if you have it on one side, there's 2 bolts there to kind of try and help with that levering, but adding that other face here really helps that from any type of movement at all, which is good. And I think I'm going to go ahead and leave that way. We're just going to make this look a little bit better. So we're going to go edit this sketch here. Click there. Okay, and I'm going to go ahead and use the arc tool. And we'll do 3-point arc. We're going to go from there to maybe there. And just kind of make that a little bit better. So if I go back to my, do that, like that, and that looks better, I think. Turn that sketch off. And we have that there. It's not great looking, but it definitely will hold the sensor. It's not symmetrical though, which does kind of bug me a little bit. I probably could take that a little bit further over maybe. It's cutting in there. Right about there, it looks to be all right. I don't know how to do a tangent, Aaron. Right there, is that the tangent? That looks pretty good. Maybe that was it. I thought it was supposed to be the circle with the line to mean the tangent. I don't know the shortcut for that. Again, I'm not a Fusion professional by any way, shape, or form. But like if I hit T, I don't know what that does. Yeah, I don't know how to create a tangent. Let's see what Aaron says back here. Chat lags behind the video a little bit, so. I don't have it in my little shortcut here. So on my screen, I do have some Fusion360 shortcuts. So S is model toolbox, Q is push pull, C for circle, D for dimension, L for line, X construction, P for project, Control Z, and joint. It is a constraint. Yeah, I just don't know how to do those constraints. Tangent. Okay. If I highlight that. Okay, so let's select this curve, I guess. And if I do tangent to that one, there it goes. There it was. So I just had to click the arc I had to the arc I wanted to tangent to, and bada bing, bada boom, there it is. Okay, see? Learn something new every day here. Doggone flying stupid ants. Okay, so it definitely has the strong crab arm on this side and not so much there, but it clears, which is really what we wanted to be sure of. And to really test out that clearance, I did find on GrabCAD the Easy ABL model. So we're going to go ahead and just pull the Easy ABL in. And we'll be able to verify. Change the pivot point to right in the center of this thing. We're going to roughly line this up. I can always align it a little later there, though. So let's just put it off to the side because it's a bit easier to align later. So we're going to do modify and align. We want to align that. Control or Alt Control. There we go. To there. And we're going to hit OK. And then we can just select the Easy ABL, move it. Let's change the pivot point again to the center. OK. Pull that up like so. OK. And yeah, so that now if we go and hit this button up here, we can see everything now. And we can see that clearly the Easy ABL will clear the carriage, which you wanted, or the back part of the clamp. We wanted to make sure that was not going to be impeded. Now, looking at this, I might need a little bit of support here. Whoops. So we can fix that by just going and adding a chamfer on the back here. Again, it doesn't have to be a lot. It can be a little bit. You can also add it as a fillet. Maybe a fillet look a little more. Okay, so if we do that, there we go. Shouldn't need support. Well, actually, I won't need support either way, but I like the fillet. We're gonna add a little bit of fillet, get a little more strength on this thing. Because I can print this on one side. I mean, it can print on its face. It's separate from the actual part. But we did forget one thing. We forgot the holes. So we're gonna go back here. And the easy ABL, we're gonna pull that out maybe. Can I pull that out? Capture position. No, it's inside there. Okay, that's fine. Whatevskis. We are going to isolate the sensor holder again over here, and I need to just hide the main body there. And I'm just going to go ahead and click extrude, capture position, that hole and that hole. Just going to pull it all the way through. There is our through holes. Now we could do a little bit of, okay, so these are M3s, right? So if we do inspect that hole, 3.3, yeah. So those are M3s. I'm going to use socket cap head M3s, like this one here. Okay, so we'll take our calipers and we're going to measure out, and these are 5.4 millimeters. So if we do 5.6 millimeters, or do 5.7 maybe, we can make that. So let's create a sketch here. Center, we do 5.7. That's going to be too big. Even 5.6, too big. Okay, so I guess we won't then. I was just going to get a bit fancy. Delete that sketch. We don't need it. With the that on, turn that on. But at least now we know that that can move. There we go. Save that now. But all these I'll be able to attach that on there. I was kind of wanting to make it a little more nice, but hey, that's okay. I think that'd be pretty good. And he did have a light chamfer on it. I don't think it needs it. I mean, this is a purely utilitarian part of the printer. There's no, we're not going for any aesthetics on this thing whatsoever. So this should work out well. Printing it on one side, and you're not going to see, even though I put fillets on it, it's not going to change anything because the sensor is going to clamp down using two nuts on either side, and those like kind of locking type washers. They're kind of weird on ABL sensors. They got like all the fingers in the middle, and those will all lock in there. And die. But yeah, so you're not going to see that anyways, and this should give me enough clearance. So what I can do is I can go ahead and attach the sensor to this part and then screw it on to the hot end carriage, making it align very easily. So again, we started out with, was starting over here. We're just going to delete that because that's just crap. But we did start out with the idea coming from this model here, and now he did it, also made it way lower, or the one I did is a little bit higher up, which is fine. The Easy ABL has a pretty large sensing distance, which works in my favor, but I'll be able to get it down low enough to line up with the hot end. And again, this is the original step for the printer. I mean, he's even got a spool of filament in there and everything like that. So I like the printer. I really do. I think it's pretty cool. I did mine a little bit differently. I made mine a little bit taller so I can have like electronics underneath. And I'm using the foam core board to hide all of that away, hide all my crimes, basically. So my cable management doesn't have to be perfect under there, but it's definitely not as good as I want it to be. One thing with Core XY machines is the cable length for the motors is quite large. Board's back here. This motor's fine. This motor's got a long way to go. Your extruder's got a long way to go. And I'm using, I think I'm using 1 meter cables on these, and they just like barely reach. And then your Z is like literally 5 inches away from the board. So it's not a big deal, but on big Core XYs like the BLV, man, those cables are super long, or they could be. But he has the motors in the back instead of at the front. So again, it's kind of whatever way you really want to go. If you put them in the back, you pull the bed a little more forward. If you put them in the front, you can pull the bed a little more back. So it kind of can decide which way you want to go with that. But I think definitely on the right track. So I'm going to go ahead and get this exported. So and we're going to save out all 3 of these parts because I have to print all 3 of these. We got the main body, Dave's STL, to the desktop there. And then we've got the sensor holder, main body for that, save as STL. Okay, and sensor holder. And then we've got the 40mm fan clamp, save as STL. Okay, okay there. And then we go here to Simplify 3D. We can delete out this one and that one, and I'll import the new models from the desktop. Got the main body, sensor holder, for fan clamp. Okay, so it's pretty simple. Control L. Lay on that face there. We're going to go on this face here. It should work out. And then that's already on its face. So we can do center and arrange. Oh, you guys aren't even seeing. Oh, I'm sorry. I totally forgot to change up here. But either way, here we have the models all ready to go. So I could print. I think I can do it on this back one with no support. There shouldn't be any support needed on this here. That should work out just fine. Same orientation as this. No support needed in any of these parts. Those are all fillets in there. So yeah, I just need to print out these parts. And let's edit that. It's on the HyperCube. We're going to print this in PETG. We are going to do 0.2. We're going to do 3 perimeters, 4 tops, 4 bottoms is fine. 20% infill is good. We're going to make sure infill is going to be honeycomb. Prepare to print. And there we have stuff. Cool. I'm going to go higher than 20%. But it should be fine. I think that's what I'm doing right now. I think he actually recommends 30% in his original ones. So we'll go up to 30 on one. Yeah. Paul's going to print there. There's a bit of bridging. Nothing too extreme. Yeah, that should print and work out pretty well. Let me see here. Hey Jesse, how you doing, man? Sorry, I wasn't reading chat there. Type for the MT evolution of the heave art. It's basically reading. Yeah, HyperCube definitely has its place, and I think definitely now it had its place. The HyperCube really threw the Core XY market right into the limelight. Like it really did. This was the first, not the first, but this was like, I mean, the Volrons have been around for a while and they've been HBots, but like, I don't know, like no one really heard about many Core XYs until the HyperCube was put out by Tech2C. And that really threw the Core XY machines into the mainstream, in my opinion. Yes, it is a full DIY build. There's no kits. Well, there are kits now, but like there weren't kits back then for this machine. You can buy a kit for pretty much anything these days. I mean, the BLV was a kit that I started with and kind of evolved from there. But that's just kind of like how it started. And I really think that a lot of credit needs to be given to Tech2C for bringing the Core XY a little more mainstream. Now, again, I could be off on that, but it was, in my opinion, the one that kind of accelerated this kinematic in the 3D printing community for the most part. And it was affordable. That's the other thing, is that Volrons are super expensive. They were around when this came out a few years ago. Everyone talked about them. The HBot, and what was the other one that was really big like 3 years ago, 2017? It was an HBot type. There was the Volron, and there was this one other one that everyone talked about until this thing came around and really changed things up. But I mean, this whole thing can be built for, I mean, heck, what was this, like 250, 300 bucks? I mean, it's really not that expensive. you're 3D printing a lot of the parts, your biggest expense is always your electronics. Extrusion's super cheap these days. This is one stick of 2040, and I think 2 or 3 sticks of 2020 at $7 a piece. CBOT, there it was, Aaron. Which I never really saw much of those. And then there was a lot of Ultimaker clones about 3 years ago as well. That there was a bunch. There was like this thing was called like the Jessie, came on at AliExpress. Was the big Ultimaker clone that a lot of people were buying, but it was like $2,000 for a clone. Like, well, just spend an extra $1,000, buy the real thing. Anyways, it's really not a big cost because I think Ziltech sells extrusion for like $7 for 2020 for a meter. Like, the whole frame costs like $30, which is like ridiculously cheap. That's also what kind of makes the Bear so appealing. You can buy the frame from Prusa or from anybody else for $100. You can buy 3 sticks of 2040 for $30. Which one are you going to go with? Like, obviously, the 2040 is way cheaper. It's easier to make. It's made in such high capacity. Where to get a Prusa frame, you got to get that laser cut to be the right size and all that jazz. So I just really like using 2040 for the 2020 2040 for the base of my printers because they're just so customizable. I can attach anything I want to this. I have on the front of the FT5 a little GoPro mount that kind of mounts on there. Get away from me. And I can attach the same one here, hang the GoPro down upside down, and get a time lapse of my print. Makes it really easy to do. 2040, 2020s, all the 20 millimeter extrusion just really has a lot of options for you. Yeah, the old Stratus works on machines, 35K, down to the reasonable price of a HyperCube and Volron. I mean, compared to 35K, Volron is a steal because you can make those like their prime one for like what, less than $2,000 or right around $2,000, I think is what they kind of spec it out to be. But yeah, I mean, there's a lot of things I like about this. Again, we talked about it on the stream on Saturday on like some of the design choices that Tech2C went with and some things he didn't do. Again, it's neither here nor there. I made this a few years ago and have been kind of evolving it since then. And now I'm kind of getting a little more TLC in order to get it kind of where I want it to be to start using it more again. And I really want to use it more again. It's just been very, very neglected because I've just had so many other machines I've been working on. And if I can have a good workhorse, I mean, there are no artifacts in like the walls on these prints. Let me show you some of the walls on here. This thing, I mean, it puts it to work. If my camera will focus. I mean, this thing goes to work really well. I guess this is like a cheap no-name filament. And if it can do this well with the cheap stuff, you throw some good stuff on there, and it's even better. I mean, that's the kind of the nice things about the Core XYs with a Bowden setup. And I could do direct drives. The BLV is going to be a direct drive. I'm not really expecting, which is kind of sad, at a printer that costs 3 times the amount. I'm not expecting the same print quality that I get out of this machine from the BLV simply because this one is just so simple. And we talked about how Tech2C really followed the KISS method, you know, keep it stupid simple or keep it simple stupid. And it really showed how easy it was to mount all of this and get everything in and how modular it is. Like, he made this hot end assembly so modular. Like the X carriage is completely modular. 3 screws will hold that on. You can change out anything you want. He put a laser on his. I think he put a CNC, a little spindle on his as well. People have put pencils, pens on here to have a drawing machine. Like, just have to have those 3 holes. Like, that's all you really need. So I do appreciate the work that he had done to kind of get this to where it was, and it really threw the more DIY 3D printing design market mentality into the future. It really did. It propelled a lot of things. Beryl, I hope you watch my Two Tree Sapphire Pro videos because I had the worst time with that machine. I did live streams with it and hung out with the guys on Discord. I probably put in a good 40 or 50 hours into printing, designing, modifying Marlin into that printer to get it to actually function. Once it did that, it printed pretty good, but be prepared for a lot of work on that, man, because it was a brutal machine. So I did think about that, Aaron, the Mobius. Again, it looks cool. I want to keep with the I want to keep with the design of the HyperCube for this in the way it is right now. If we go to do a redesign, and again, it's something that Aaron and I create and make, I will use this thing for that. I don't want to because, again, I spent so much time. I did huge tutorial videos on this, which also kind of broke me from doing those videos and doing more of the live stream stuff when I'm building things because those videos took forever to make. And I know my production quality is not fantastic, but man, stitching all that together and making sure I had the angles and showing where things went, how they went together, and having all the parts printed, having everything there, the amount of time that took was brutal. I also only had 3 kids back then. It was a lot easier to do that kind of stuff. Now with 5, not so much. I really don't have the time to ensure I have all that stuff perfectly put together all the time. I also have the space. You guys see my space here is very small. Maybe when I move next year, I'll have a larger space, make it easier to have a actual like workshop space. But like right now, I use these plastic bins for all my projects that are ongoing or upcoming to try and stay organized. But if I had like a separate desk to do this on, like I had in my last place, and also less printers, it could be a different story. So the sure, oh, I did see that tiny direct drive one, but wasn't it like $100? Like it's just insane. Yeah, it was a barrel. Yeah, so CNC Kitchen, his was actually bowed. Thankfully, mine was not. But so structurally, it was fine. Mechanically, it was an absolute disaster. I mean, it just nothing worked on that thing. The driver's issue was my novice because that was the first time I really dealt with some of that board and part of Marlin 2. So a little bit of that in the beginning was me. But once I figured that part out, a lot of it was just the machine was not great and just required a lot of work to get done, the belt tensioning and all that jazz. So, um, yeah, motor's only 20 bucks, but the hot end was like insanely expensive. I did think about doing something like this. I thought about different heads. Again, there is a Mark III's Bowden head that bolts right onto this that I did like. My only thing with that is that I guess it really wouldn't matter because I was worried about the fan coming out the front. I wanted to keep this because where it homes here, homes over here, okay. Once it's homed, I was worried about just anything out the front on that. But that is also another option. I just unbolt this, clamp this V6 into that new one, and it's pretty much off to the races. It doesn't really require a whole lot. It just gives you the moves the part cooling fan from up top down below. The one from Tech 2C, again, keep it stupid simple. It just puts right out the back. And if I can get overhangs as good as it does with this, there's no real reason to change out that. I mean, there are a few that have done like the C, so it comes down and kind of spreads out the air a little bit more. It works really well just like this, in my opinion, so I'll keep it that way. I'm also running carbon fiber rods with I just bushings in here. Seem to be working really well still to today. They just need to dust it off a little bit. But yeah, I'm pretty happy with it. So I'm gonna go ahead and we're gonna go ahead and get these parts queued up here. So let's turn the machine on. And again, the loudest part of this machine is this 30mm fan, which I'm all for trying to get the machines as quiet as possible. And I also think putting on a good quality sun-on fan, a 40mm sun-on fan, will definitely cool better than this little 30mm fan will. It does move a lot of air, don't get me wrong, but it's just so loud. I'd like it to be quieter. So let me get this going here. So we're going to save this out. I'm just going to call this HyperCube parts. Okay. I have to have the SD card in to then reboot and then for it to connect. And we'll hear the little beep. The beep. There it is. It's good to go. So we're going to do print, part, HyperCube parts. There it is. I really like that screen. It's so crisp. I've never had a touchscreen that crisp before on how well it just works. So Aaron said he shared something with me in Fusion. Let me check that out now. Has V6 clone coming because it doesn't feel like bumping dragging into it. Generate preferences when looking at ABL mounting and sensor design. So specifically for the Sapphire Pro, I ended up putting on a BL Touch that I had laying around, and I found on Thingiverse a BL Touch mount. So I was able to go ahead and just add that rate to it. It puts it on the back, I believe, there. Easy enough to do. I just try and look when I design or I try to decide where to put an ABL mount when I'm looking at designs, or I'm designing it myself, or I'm working with Aaron on designs. It's just about where it's not going to collide with anything. And so when you're looking at an i3 style, you have to make sure that your frame is wide enough if you want to put it to the side of the hot end. That's the reason why I could not use the Easy ABL on Megatron. I could have. I made the frame wider, so it's still same size bed, but the frame is just wide. It gives you a little extra buffer room, because when it would go all the way over to print on the right side, as it's printing, it goes all the way to the right side. Well, for you guys over here, the motor's right here. It would crash because it's so far over from the hot end. The ABL would crash into the Z motor mount unless you move the Z motor out more, and then you have the space. But again, the Easy ABL is a girthy boy. It is 18mm wide. Most of the ones that I use are 8mm. So it doesn't seem like a lot, but it is. You know, it's an extra 15 or anywhere from 10 to 20mm wider on your y-axis, because you got to keep it symmetrical. So it's actually up to 30mm wider in order to accommodate for that ABL sensor. Other people can put it behind the carriage, but again, you have to just make sure that you have the travel distance. If your bed does not move far enough forward, then you can't probe the back of the bed. Or in this case, you got to be careful that when I'm printing at the very back, because I don't even get to the back of the bed as it is in this orientation, it would crash on the Z rods or the Z lead screw. That's another problem you have to worry about. So there are lots of things to consider when deciding where to put your ABL when you're designing parts, or when you're looking what other people have done. Because what works out for someone may or may not work out well for you. Operator Neptune says, I'm looking into doing a HyperCube Evolution. And the Evolution was out when I was originally building this. I think it came out shortly after I started. I personally think the Evolution is overkill. That's just my personal opinion. I don't think a printer with a 210 by 210 bed needs to be made out of 30/30 extrusion. 2020 is more than enough if you build it right. Like it's kind of plain and simple like that. There's no reason why this 2020 frame should not be sturdy enough. It's good enough for the FT5. It doesn't twist or bend anything like that. That's a 300 by 300 by 300 printer. And it weighs a metric ton because of how much extrusion is in it and how much it's used. And now I have aluminum parts in it. For me, it's not needed. If you're going to go over 300, I say yes. Go HyperCube Evolution, 3030 extrusion. Absolutely. I think it'd be more necessary for something that big. Or what the BLV is doing is using 2040. Going either of those routes would be better. But if you're just doing a small printer like this, again, this is a very, very small printer. 200, or I think it's like, I'm getting the 200 on the X, or like 190. I'm getting like 170 on Y, and I'm getting around 200 to 230 on the Z. Not a big printer, but this thing is for like super precise prints that will work well with a Bowden. The Z Direct Drive is a little better, but it definitely is for like super precise printing because the mass of the head is so light, and Core XYs have two motors working together to move X and Y. So that's why you can get higher resolution with a Core XY than you can an i3. So he's got a 310 Voron, sturdy with 2020. Yeah, again, if you're going to go more than 300, so if you're at the 300 range, stick with 2020, 2040 if you really want to. But anything larger than that, 400, 500 cube, you need to get some beefier extrusion, 2040 or 3030. So again, Beryl, that's a local thing for you. For me, I can't get extrusion locally, so I have to order online. 2020 is the cheapest you can get. Again, it's $7 a meter on Ziltech. I'm going to look that up right now, actually, because I think that's what it was. Ziltech.com. Let's go here. We can share that there. Lumen extrusion, 2020 T-slot. We're using T-slot for this. And we're going to go down to, there's a 10-pack for $57. That's $5.70 per meter if you order their 10-pack. If you order it straight up, make sure this is actually extruding properly. It's doing okay. Where is there? There's a 20-pack of extrusion. Come on, where's it at here? Yeah, because 3030 is different. Lumen extrusion, it's custom cut service. I don't want that. They also will cut it for you, which is nice. So Ziltech is, in my opinion, the best place to get it from. Also, so that's $570 before my coupon, and my coupon gets you guys 15% off. It's down in the description. I think it's just Fugatech 3D. So either my coupon will make it cheaper or will cover your shipping for the most part, unless you live somewhere like crazy out there. But you get an additional 15% off of that with my coupon. So, I mean, you can't really beat it, in my opinion. Again, this is where I order from. I ordered a huge amount. So here's 2020 pre-cut lengths. So if we select 1 meter, it's $5.95 if you order 1 meter. You can go up to 2 meters, and it's $12.95. I normally order in 1 meter or 1200. It's only $1 to add an extra 200 millimeters on there. So again, if you need T-slot, this is the absolute cheapest place to get it. And you can use T-slot for pretty much any 3D printer that doesn't use rollers. You should be using T-slot. There's no reason to use V-slot any other way. Also, Ziltech is where I get all of my hammered T-nuts from. It's where I get all of my M4 and M5 hardware from because it's just so cheap. I really don't have a reason not to buy from them because their prices are insane. It's a US company. Now, granted, yes, they import all their stuff from China, obviously, like most people do. But I mean, 100 M4s, black M4s by 10 millimeters for $4.95. So, again, things here are cheap. They are definitely good quality. They own their own extrusion line, apparently in China. That's where they get all their filament from, is from China. But it's cheaper to manufacture it there and ship it in by the container to the US. So that's what they do. Also, they don't have the expertise in-house to run an extrusion line. I like them, and I will always promote their business. Yeah, so here's 100 2020 T-nuts. So you can choose your size. So they have M4s, $10, M5s, $10 for 100 of them. M5s are sold out. M4s are still in stock. But this is where I get stuff. And again, you get anything you buy on the site, you get 15% off if you use the Fugatech 3D link below. Yes, it's affiliate link. Yes, I get a cut of that. I appreciate it. But honestly, there is nowhere cheaper than this. And they do a, so since we're talking about the HyperCube, if you do want to do a HyperCube build, you can buy a kit from them. Now, I don't, I can't really recommend it because I've never used it, but they have like full electronics kits. They have just hardware kits. They've got everything kits. I mean, they've got a whole lot on here for that. And again, you get 15% off of this. So they have their $350 for HyperCube Evo frame kit, 400 by 500 build volume. That's insane. $350 out of stock. Here's a HyperCube 200 full kit for $300. So you get a full HyperCube kit, 200 cubic build volume, so 200 by 2 by 200 for $300. And you had to buy one thing from one company and print your own parts. You take another $45 off of that with the coupon, and then you got to worry about shipping. But either way, it's sold out. They've got a bunch of other ones here as well. Either way, again, I personally have found them to be the cheapest for most things, and it's good quality. You know, and again, having a coupon really helps because I use the coupon too, like to buy stuff. I just don't get any credit for my own buys, which kind of sucks because I dropped a couple $100 on filament and things. So you will notice Hyper Neptune, they do have a lot of out of stock because they just moved. So I was sharing on Facebook this past Friday, they just did a Facebook Live tour of their new warehouse. Since I have been buying from them, so in the past 3.5 years, this is their third, well, this is technically their second move. It's their third building that they have moved into. It just, it's amazing at how much Ziltech has grown over the past 3 years because they were a little bit of nobody and now they're a huge company. And I mean, they don't have that many people. They got what, maybe a dozen or 20 people. But their warehouse is enormous. I highly suggest you guys go check out their new warehouse place. But they actually have an extrusion cutting place, and like they do the cutting service for you. It is a enormous building, and I'm so happy to see a U.S. company figure out how to continue to grow even through COVID. Like they moved during COVID, which is crazy that they were able to do that. And they have just been out of stock on everything. Their filaments have been sold out because of PPE. Like they cannot keep the stuff in stock. But now their new warehouse, man, they rolled into the actual, like they call it the forklift zone. Man, they have huge racks, you know, good, 20 foot tall racks with pallets upon pallets of materials. So I don't think they have everything put into the site yet. But again, if you're looking for a US company that's a really good price, I would buy from them. I like their filament. I have boxes of it. I just got a whole nother shipment up here. I've got several boxes over there, some of the new colors that I bought. So this is all Ziltech filament here. And then I have a whole 1, 2, 3. I bought a 5-pack of PETG. And then I bought some green for Christmas. And then they had a new sparkle color. Those are some new PETG colors that they had that I bought. I mean, they don't send me filament. Like, they don't have to. That's the thing. They sell so much, they don't have to send me filament. Like, I will happily buy their filament and I will happily showcase it because I like it. It works out really well. I'm printing with black PETG right now. This is Ziltech Black PETG that's on the spool. Works great. So it wasn't really the way I wanted this to go, but again, I'm happy to throw some business their way because I think they do a good job on what they do. They found a way to make it work. Yeah, they don't make their own filament in-house, but that's really expensive, and they have to like pay operators. Like Printed Solid's gone that route. Awesome stuff. Like good for them. They have the staff to do it. So far, I like it. It doesn't work on this printer. I need to investigate why that spool's not working, but it's new to me. That's what Dave wants to do with his business. Hey, by all means, manufacture your filament in-house. That's what a lot of people want to see. You know, the good old made in America bit. So 10x10 probe and the Ender 3. Yeah. A lot of people are going to on the Bear and the Prussias, they're going to 7x7 grid. I'm still running, so I now have a 5x5 on Megatron. I think I did a 5x5 on the Bear as well, and my original Prusia is still running a 3x3, which still works perfectly fine. Like I have little to no issues with that at all. Or I shouldn't say little to no. I have no issues with that at all. So it just works out well. So I just love watching the first layers go down. I'm a little close, but that's okay. I'd rather be a little close, a little far to make sure we get a good first layer. Ooh, excuse me, bond onto that ultra base. Oh, okay. Sorry, Aaron. Yes, I got distracted. So need to change here to geared. Save what I did there. Aaron, can I show this on the stream or no? You me just looking at myself. Have to request access, Aaron. Yeah, for the actual printer, you have to give me access. So while we wait for Aaron to do that, we can do this here. So this is the Sherpa Mini tool head that looks like Aaron is looking at using for the hot end. It's going to be Bowden, looks like. But he also has this Sherpa Mini extruder, which we were talking about earlier in the stream a little bit. I'll wait for you to give me access, Aaron. So now that both Aaron and I have, Aaron's had a license for Fusion. Now, since I bought a license, we can do teams in Fusion 360, which is really helpful. So if you're designing stuff with other people, you can do it together. So this is the Sherpa extruder. I think this goes on there. I'll try Open Frenzy again. Yeah, I can't perform this action. May not be a member of other project, or the project may be archived. Request access. But this is that wee little extruder they were talking about. And it uses this tiny, this is a round pancake stepper that is what, 20 bucks, I think, or less. And uses some Bondtech gears, so it's dual drive. And yeah, so this was kind of an idea on what to put, I guess, on top of here, maybe? I don't know. Something just fell off. What just fell? Oh, it was the cat. He's stretching. You can see the cat right here. He's laying down by the bear, the bear printer. Open. Don't have access, Aaron. Yeah, it says Sherpa Mini V0 toolhead. So I guess this is for the Voron 0 whatever. It uses two 4010 fans on it. Did you get an email, Aaron, to like give me access or something? Let me close Fusion. Let me close Fusion and reopen it, see if that changes anything. Order. Hey, Fortnite, what's up, dude? Geared. Frenzy. Frenzy. Yep, still doesn't let me. Don't know why, Aaron. I'm doing all right. I don't know. You got it. Oh, got the email, I guess. Are you working now? Maybe. It's thinking about it. Switch over here. It's thinking about it. Come on, Fusion. It's asking what type of bushing I am using for the carbon fiber shoes. It's not what I'm gonna use, it's what I am using. So they are IGES bushings. This is 10 millimeter carbon fiber tube, and IGES has bushings for that. They are a plastic polymer bushing. I think if you go back to my original HyperCube videos, you should be able to see a link down below to where I linked those parts. They all should be in there, so you can go check that out. All right, here we go. So this is the early design of the Frenzy, and yeah, so that is it's direct drive, but like not quite, because there is a piece of PTFE that's going to go from the hot end up to there. So it's not fully direct drive, but it's really, really close to it. That's what the what's called the same way. The BLV is the same way. It's got an extra longer piece of PTFE tube in there, but it is straight in line with the extruder. So that's where that little baby extruder hops onto. And so this is all using 2020 extrusion is for the outer frame. And then it's using a piece of 1010 extrusion for the x-axis with a linear rail slapped on the front of it. Linear rails on Y as well. And Z, I don't know what Z will be, and I don't know if we're going to use dual or single. I kind of like the way that the BLV has the dual Z with the linear rails, but this is not a huge build volume. You know, right now it's just a 180 by 180 bed that's in there. I believe these are 9 millimeter rails. These should be MGN 9s, which again, for a printer this small, should be fine. But yeah, kind of borrowing from the Voron 0 there. Oh, that has to go further down. It's not really aligned yet. But yeah, again, this is all super early concepts because like obviously like these are just square blocks for the end there. Like nothing's been sexed up at all. Like it's very, very early design on what to think. So the things that we did talk about was where to put the motors, and Aaron came to the conclusion that it would be better to put them in the back of the printer than the front, like the HyperCube has them here on the front. So both motors are right here. On the BLV, both motors are in the back. So you kind of eliminate that from the front. You can get away with just a idler or even an idler tensioner system like the BLV has. But again, once the belts are tight, you really shouldn't have to be tightening them very often. It is a nice, it looks nice. I think it's a cool feature, but is it really necessary? Not really. This is still going okay. But yeah, so this is kind of like the things that we've been wanting to do. And again, I want to devote time into this come later in the year, you know, maybe come like December, hoping to finish up with these other projects that I have going on and be able to devote some serious design and testing time into this. The nice thing is that I have enough printers and filament that I can kind of just throw a bunch of filament at this project and test out things. But yeah. All right, Aaron, take it easy, man. So yeah, so this is calling it Frenzy right now. I don't know if that's gonna be the final name. Because we've got a very big transformer thing going with a lot of the printers that we've been working on lately. But yeah, so this is the early version of the Core XY that we kind of want to design. So am I printing that extruder yourself or having it done SLS? I will probably print it myself. Because there's no one even in the country that does SLS. But it should be fine. I mean, should be. Again, this is what we are thinking about using. We definitely have not made any decisions. But yeah, I mean, it's a very early version of what we want to do here soon. Why is two head rail vertical instead of horizontal? Because that's how they do it in the Voron. And again, we're kind of borrowing this original part from the Voron, and that's how they have it mounted on there on the V0. What do you think about 3D printed extrusions for ultra budget rep wraps? So let's think about that. I've seen a few of those done. I think Country 3D, I think he had done a few fully 3D printed machines, an i3 and I think a Core XY. I honestly don't think it's worth it because aluminum extrusion, it's going to end up being cheaper or just as much to use 2020 aluminum extrusion than it is to print it yourself. So look at Ziltech. I just showed you guys $5. It'll be less than $5 for a meter. And is it going to cost you? How much money is it going to cost you to print a meter in a PLA or PETG? The cheapest you're going to get PLA from Ziltech is like $13 a spool, $15 or $16 for PETG about. So you're going to be using a lot of filament because you're going to have to print it with pretty much 100% infill or near it, 30% infill with like 5-6 walls to ensure it doesn't crack or anything. Very high temperature. Got to make sure you get that layer bond really, really well. So you're going to have to print hot in order to ensure you get good layer adhesion. I don't really think it's a good budget. You can do so much more. Spend $30 on frame and then cheap out everything else. Well, the way this is, I mean, this was not designed. I think he pulled this straight from it. So I think it'd be mounted either way. Oh, I see the mounts are up there too. Again, I don't know. This is kind of what we've been thinking, what we're working on. We'll kind of see how it goes from there. it's not heavy either way. So having it be vertically mounted shouldn't really matter. You're still riding on a full ball track because Y is mounted that way as well, which is also easy to do. And the weights we're talking about here shouldn't really affect these linear rails. If they do, they're junk linear rails, to be honest. But we're talking, you know, what, a pound, if that, riding on these, as long as they are level to each other, perpendicular to each other, shouldn't really be a problem whether you do horizontal or vertical. Really should not matter. So cardboard for the build surface. Well, I wouldn't do that. I am a big proponent of not using wood or basically anything flammable, like near your hot end. I would not use flammable items. Like there was somebody who was talking a couple weeks ago, one of the streams, dude was on something, but using a piece of plywood or MDF as the build surface. I'm like, you're going to put a 200 centigrade hot end near that. Now, granted, it takes more than just heat to create a fire, but I wouldn't do it at all. You can cheap out a lot of things. Build plates are super cheap. Getting a piece on Master Crane over here, I created the bed carriage and the bed for $7, I think it was, because I went on to eBay and bought 3mm aluminum, and everything was like $3.50 a piece, and it was like $1 or $2 for shipping. Like, that's kind of a no-brainer. There are definitely ways that you can cheap out on printers. Definitely ways you can do it. But there are certain things, in my opinion, you should not cheap out on. Go with aluminum frame, go with an aluminum bed, and aluminum carriage. That's kind of like it. You can do a lot of other things other than that, but like, you can buy a $2 hot end. You can buy $3 motors. All of that's fine. You can buy cheap bearings, cheap rods, all that jazz. Again, you play the China lottery when you do that, but hey, if it comes in and works out for you, great. It usually works out for me. I see horror stories, but most of the time, mine ends up working out well. You can definitely cheap out on a lot of things, but the frame, bed, and build surface, I would not cheap out on. Personal opinion there. Yeah, just don't build out of flammable things. Now, acrylic frames were good for the time. Buying an acrylic frame in 2020, dumbest thing you can do. But back in 2016, when I started 3D printing, acrylic frames were huge. The ANET A8 was the hottest selling printer for years using the acrylic frame. I ended up going with the G-Tech i3 aluminum. It was an aluminum frame, but G-Tech also had a acrylic framed 3D printer that I almost bought. I think it was their Pro B or something like that. Late 2015, early 2016 model that they had. It had its place in time. Now is not that time because extrusion has come down so much in price in the last 4 years. There's no reason not to buy it. You know, so printed bearings, I probably wouldn't go that cheap either. But like, again, you can get the LM8 UU bearings are what, 49 cents on AliExpress. I just bought a whole bunch. They're actually almost just as cheap on Amazon with free shipping. So if you factor in the shipping plus the bearing cost on AliExpress, you look at Amazon, they're literally almost identical price. I think you pay like $1 in total on Amazon, and you get it in a couple days, where from AliExpress you're waiting a month or two. So, you know, See, and I would not go, I am against AC heated beds. I don't think, unless you're building a large 3D printer, 3, 4, 500 millimeters square on your build volume, an AC heated bed makes more sense because it's a lot to heat up at 24 volts. Anything 300 or smaller, you should be going with a DC bed, in my opinion. Your board can more than take it these days. If you're worried, use an external MOSFET, but again, it should be able to do it, especially 24 volt, no problem. 12 volt, I'd use an external MOSFET, but 24 volt, because you're using 24 volts, the amperage is much lower than what is on a 12 volt for the same size bed. There should be no reason to go with that. Also, again, for me personally, I can't use AC heated beds because I move so much. I could be in a 110 country. I could be in a 240 country. I don't know until I get there. I don't know until I get assigned somewhere. So for me, it is useless to have AC heated beds. Again, that's just kind of me. Oh, the kitty. Yeah, thank you. He just left now. He was hanging out down there sleeping. All the kids went to bed, so he wanted to hang out with me. I was about to bring up the A and A. Really hated them because saw a lot of issues. Frame bending, probably wise fitting. Yeah, I mean, again, acrylic frames had their place, but not really anymore. So Adam, I'm running a 340 by 340 millimeter bed on the BLV. It's 6 millimeters thick, tooled aluminum, and it has a 24 volt heated bed on it. 24 volt pad stuck to the bottom of that. Heats up just fine. Takes me about 3 minutes to get to 60C, 3 or 4 minutes to get to 60C. That's fine by me. I don't need the 1 minute heat up time. Also, you have to be really careful with AC heated beds, especially on thin aluminum, because the quick heating could cause major issues with your glass breaking. If you have glass on there, it could cause a major bowing in the aluminum, because if you don't get a thick enough bed, because it heats so fast, you could have really big issues with that, which is another reason why I'd stay away from AC heated beds unless you know what you're doing and you have the proper precautions there. Yeah, there's a lot to go with that. So again, it's just it is what you want it to be. If you're okay with doing that, then do it. But I always try to express caution with AC heated beds. They can pull a lot of amperage as well, so you have to be careful with that. There are some countries in the world that is illegal to work on AC components if you're not an electrician. I know Europe has several issues with that. Tom brought that up a while ago. I don't live in Europe. In the US, you can do it, but it is what it is. 60% duty cycle. And see, a lot of people might not know that, Adam, when they do it. They might not. Oh, AC heated bed. Everyone says AC heated beds are great. I'll throw it on there real quick. Crap. We'll see. I'm doing a 415 cube on the Hevart. Sorry, Bill. Yeah, again, 400, I could see using AC heated bed on that. I probably would too. I'd have to run a transformer on it. Here I'm 110, which is good, but depending on where I am, I might have to run a transformer. It is what it is at that point. But, again, you do you is what I come down at the end. If you're okay and comfortable doing it, by all means do it. But if you're not, please use some caution or common sense, one or the other. I think actually while I'm waiting for this, I do want to see if I can get, I'm going to put my spool rack back here. It has been so useful to have this spool rack here. I might design a little bit bigger one though, because I have some larger gauge wire that doesn't quite fit on there well. And I need to reorder my smaller 20 gauge hookup wires because they only come in 50 foot or 25 foot. It's like 50 foot. And I've used most of them up. So I need to get some new ones of that. But I did want to look at... oh, I thought I could flip this. I can't because I moved that. So I'm just going to use this as a template. This is just cheap foam core board. I have more of it downstairs. But I thought about flipping it over because it's symmetrical in the back, obviously. At least it should be. Pretty sure it is. But it's not going to work because I moved the spool holder here. So I might either A, do a different spool holder, which is always an option, or B, I'll just cut a new one of these out. But I just need to recut, use this back in the template because this fits up pretty well. And they want this to slide. It just comes in at an angle, and then you cock it sideways, and bam, you're in without too much of an issue. Yeah, that thing being there is definitely in the way. But anyways, I wanted to reuse this because I cut out the front here. The screen is now on the other side. It was on the right originally, but now it's on the left. So kind of is what it is on that. And I was debating on putting some nylon through this just to kind of keep it more oriented up. Doesn't really matter, honestly, but kind of thought about doing it to help it out a little bit. Oh man. All right. Well, we did everything I wanted to do today. I wanted to show you guys some modeling in Fusion. I always really like to share that. I know Fusion is getting a lot of hate right now because of their new changes. I bought a license for this year at least. I'm thinking that they may make some changes in the next year that might make it easier for hobbyists. Lars Christian did a video on it, explaining like people were having such a heart attack. He's like, whoa, calm down. Like, y'all don't really understand what this means. Let me explain it to you. So it basically dumbs it down, which is hilarious to watch, talking to everybody like they're stupid. But it was a good and very informational video on what the changes in Fusion actually mean. So definitely think people should check that out when looking at Fusion or using it. There's Jim. I was talking about you earlier. Yeah, Coroplast does work out well. Again, foam core is just what I had laying around. It is flame resistant. It is not flame retardant. So there is that. But I am using a PVC type material, which is a little more flame resistant, again, not flame retardant, but a little more flame resistant for the BLV. I'm also not worried about flame, to be honest. Like, if you build your printers right and you take care of them, it shouldn't be a problem. I understand it happens. It's a fluke, 1 in 18,000. I mean, look how many Prusa printers burst into flames. There's been what, like 4 that we all like really know about, maybe 5 that have really come up. And out of the what, 100, how many 100,000 has he made of that printer and shipped? So it's been, it happens. I get it. But anyways, I think I'm going to go ahead and end it there. I showed what I wanted to show tonight. I got the parts printing right now on the HyperCube, so it's really cool to build a printer and then design new parts for it and print on the same printer. That's kind of like the whole self-replicating deal that the original design of 3D printers was for self-replication and things like that. So yeah, I'm going to call it there. So thank you everybody for joining in. I hope you guys enjoyed the stream. If you want to help me out, first you need to do is become a subscriber, hit the bell icon. You'll get notifications when I do these live streams. I'm currently doing them on Mondays, Fridays, and Saturdays. I'm going to be getting into more videos soon. Live streams will become less frequent, but it's been a ton of fun hanging out with everybody in the live stream. So I really do enjoy that. This back and forth really makes the evening. It's a lot less boring than talking to the camera by myself. So I do enjoy that. But if you guys want to help out, there's ways to donate. You can do super chats. There's the Streamlabs. There's Buy Me a Coffee. You can do direct donations down there as well. There's affiliate links. Again, if you're going to do Ziltech, you want to build a HyperCube, you want to look at some extrusion. Cheapest place on the internet right now is Ziltech. There's a 15% coupon down in the description, so check that out. Again, all that money comes back here, helps me out, and become a patron as well. That money fuels all these projects, so I greatly appreciate everybody helping out. I'll see y'all later. Wash your hands. Happy printing. I'll see y'all next time.